You'll have 10 minutes for each presentation, 10 for the review, 10 for the comparative analysis. I'm keeping it in the recording mode so that I'll analyze and try to find out what else we can do here. And I want that everybody should be very sincere and not just for their presentation, also attentive towards the others' presentation.
Hello, sir, am I audible?
Yes, John, start it. Your time started now.
Okay, sir, just a minute. Next page. Okay. Okay, sir. So, a very good afternoon to respect sir and to all the people present out here.
You can
Today
keep it in the full screen mode.
okay, so that's it. That's good. So, is it okay?
Yes, yes, it is okay.
Okay. Okay. Okay, so we'll be presenting our first presentation, that is a systematic review of deep learning techniques for web-based sign languages recognition. So at first, we'll be just a minute. Okay. So in the introduction part, we that the primary communication method for hearing and speech impaired people. So the I from that how we can get the communication gap. Still a communication gap that still exists between the people who can't speak and the people who can speak. So that was the idea, and we also already know that there are various deep learning enabled automatic recognition techniques that are used for hand gestures. But still, as you all know, because our idea was to introduce a web-based deployment technique that will be used to communicate between the signers and the non-signers. So we all know that the web deployment
I
basically
think in
demands
Jamanda, your skin is cut out few part.
uh, just a minute.
In German, it is coming now. You can go ahead.
Okay, so is it visible now?
It is visible, yes.
Okay. So I was saying that the idea of ours was that we'll be using a web-based deployment technique. So as you all know that it basically demands low latency and low computational cost. And one of the major gap is that many people focuses on the accuracy, that how much accuracy a model is giving, but they often ignore the deployability. So that was one of the thought that was in our head. And the research objectives of our was to analyze a deep learning SLR approaches after 2020 so that it matches the trend. We thought of classifying the models based on architecture. As you all know that when we talk about any models in the latest version, the CNN is the most prominent one. So we also thought that how CNN, because many people are using CNN, so we just wanted to see that how CNN is working more perfectly. And we know that there are many lightweight networks because we'll be using video based, so we need a detection based model also. But we also came to know that we also have to be objective because of the hybrid models, because we need hybrid models, because only using, because we have uh, research and we got to know that only CNN will not be sufficient for building a perfect model. There are many things, objectives like comparing the accuracy, complexity, and real-time performances. As I've already mentioned, that I'll be also will be using the web-based environment. So that was also, and as I've already mentioned about the research gaps and limitations. So and the methodology that we will be using, and the way that we have taken the information from that the Google Scholar, IEEE Explore, Spring research strategy. And in doing all this research, we have got some of the common keywords, because we have explored more than 30 plus research papers, and these are some of the common keywords that we have got and how we can improve the accuracy, not only the accuracy but also the movement, because we will be using a video based technique. So we also have to see how much it is giving accuracy. So after getting all the 30 plus research papers, I guess it will be approximately 35 papers. So we got to know that CNN is one of the most prominent model that is being used at current time. But with CNN, the word mobile net also comes, because I have already mentioned that CNN is, of course, we have to agree that CNN is basically one of the most trending topics at current time. But one of the major disadvantages of CNN is it's used for effective for static sign recognition, but our one is video based, because only doing it for only the images will not work. We also have to convert it into video. So for video, CNN is not that much of useful for dynamically using of sign languages. In one of the paper, we have also got that it has achieved accuracy up to 99.98% ResNet. As I've already mentioned, the limitation is basically about that it cannot capture temporal information. And for that reason, the accuracy also decreases. And use of models like MobileNet, it designed for resource constrained systems. That is, it is basically and specifically used for videography. So one thought came to our mind that how can we use CNN with a lightweight model so that it can give a better accuracy. And as a result, it has achieved a 85.4 of accuracy. And we have also noticed that it is fast and efficient, but it is sensitive to lightning and background noise. So these are some of the approaches that we have come come to our notice, and that was from my side. And the next part of the presentation will be taken over by Madhya.
Am I audible, sir?
Yes, yes, go ahead.
Now I will explain the YOLO-based approaches, which is used in sign language recognition. The main contents are YOLO help in real-time gesture detection, which is important for the live system and real-time system. Optimized YOLO V5 models reduces parameter by nearly 90%. And these models achieve very fast execution time of about 1.1 millisecond. Yellow version 8 uh, hybrid model, which is highly performance with 99.5% MAP, and yellow model have limitation of continuous sign recognition. And finally, the first consecutive sign may cause transaction error between gesture. Next is hybrid transformer and transformer based hybrid and transformer based model. Hybrid model combine CNN with LSTM. This model captures both spatial and temporal features, and combination of LSTM and CNN we get accuracy of 98.86%. Browser deployment is difficult because of high latency. And transformation model perform well for continuous sign language detection. It provides high accuracy for long sign sequence. Transformation model also are expensive, therefore the model are not ideal for web-based application. Next is research gaps. Research gaps are highly dependent on heavy deep learning model. Browser latency and user experience are no papers, and many studies don't use standard dataset. Finally, there is a need of a lightweight and also a robust hybrid architecture for our project. Next, conclusion. In conclusion, uh, we found that lightweight deep learning model provide the best balance between accuracy and efficiency. Deployment is important as performance, and optimized detection model improve we improve web-based application sign language recognition system. And we have got one conclusion that CNN with a lightweight model and YOLO gives a good accuracy than normal models. And in future, we aim to develop a lightweight hybrid model. And also we plan to use a standard dataset and test the model in live browser and focus that it work in a low latency devices loaded and user experience. With this, I want to conclude my presentation. Thank you.
So that was the presentation of the systematic review of our paper, and the comparative analysis paper will be done by Sneha Banerjee and Astur Rahman.
Hello, sir. Am I audible?
Yes, you are audible, but in the last one, I have some comments. I will go through it, but first you complete this one. Okay.
Okay, sir. Is it visible, sir?
It is visible. Please carry on.
Okay. So good afternoon, sir. Today we are going to present our topic on comparative analysis of sign language recognition system. So sign language recognition is an important area of research that helps to bridge the communication gap between the hearing and speech impaired communities and the rest of society. So in this presentation, we will compare different sign language recognition system, understand how they work, and analyze their strength and limitation. So let's begin our slide. So this slides gives an overview of our comparative analysis. Comparative analysis help us understand the strength, weakness, and application of different sign language recognition system. Since existing SLR system differ widely in their methodology and performance, a structured comparison becomes necessary. So in our analysis, we have evaluated that SLR system based on the four main factors. First is the type of recognition we use. Second is the data acquisition method. Third is the feature extraction techniques. And the final one is the learning model and their performance. So this slides compares sign language recognition system based on their type of recognition. Some are dynamic SLR approach. So in static SLR, the input is a single image. Temporal modeling is not required because the gesture does not involve motion. It is mainly used for isolated signs such as alphabets or number, or usually gives very high accuracy. So in opposite to the static SLR, there is a dynamic SLR that is use video sequence as an input. Here temporal modeling is required because gesture involve continuous movement over the time. It is used for continuous sign and support more natural communication, through the accuracy is generally moderate and the system is more complex. So basically the observation show that the static SLR perform well for the alphabet level tasks, while dynamic SLR is more suitable for real-time and natural communication. So this slide compares sign language recognition system based on the data acquisition method. SLR system mainly differ in how gesture data is collected, either using vision-based techniques or a sensor-based techniques. In vision-based system, a camera is as perform as an input device. This system provide higher user comfort since no wearable equipment is required. They are low in cost as given in this table. They are very low in cost. The scalability is high and the practical usability is also high. But on the other hand, sensor-based systems use gloves or sensor to capture the hand movement. Though they can provide accurate motion data, they are less comfortable for user, they are costly, have limited scalability and lower practical usability. This slides show the comparison between the public and the custom dataset. Public datasets are useful for benchmarking. Benchmarking means it is a process of comparing performance, process, or product with recognized standard. So this there are two types of data set that is given here: public data set and the custom data set. So public data set, first advantage is benchmarking, and it gives reproducibility result. So they are more liable for comparison. However, they are usually collected in control environment. On the other hand, custom dataset are collected through real-time experimentations, but they are often small and sign dependent. So we have got a conclusion over here that public dataset help in generalization, where custom dataset are useful for specific experiment. So I'm requesting Asidur for the next slide.
Good afternoon, sir. Am I audible? Am I audible, sir? Hello. Hello, hello. Hello.
Hello, sir. Am I audible?
Just give me 1 minute. Hello, Sneha.
Yes, yes, sir.
Hello.
Give me 1 minute. I'm just having a conversation with one sir. So I'll come back within 2 3 minutes. Okay.
Okay, sir. Okay, sir.
Yeah. Hello. Am I audible now? Am I audible?
Yes, sir,
Yes,
you're audible.
Yes, sir.
yes, sir.
In the systematic review part, can you again show us the slides? Okay. Come back to the first slide. No, no, first, after that.
Yes, sir.
So you tell me what is the gap you have found?
Sir, the basic gap is that, sir, what we were thinking is that only a model, because there are many models, we know that the most prominent one is CNN. So what we have found is that and our problem statement is also about videography. So one of the major gap we have found is that only one normal model or like CNN will not be sufficient for us because the accuracy will not be that much. In one of the research paper we have got that
Why
because
do you think that accuracy is not as if?
sir, because sir, CNN is basically used for static images because and our one is videography. So for that reason, one in the research papers we have got that CNN with a lightweight model that can be used that is just specifically used for videography will be more good than a normal CNN model.
Okay. Then the model you have chosen is?
So right now, we have selected the CNN plus with a lightweight model will be more sufficient. And in one of the research paper, we have also got the YOLO that is basically used for videography. That is also a good architecture that we can use. So there are two or three conclusions that we have got through going through all the research papers.
So the architecture have you included in the systematic review paper?
So architecture, yes.
You have not included, I think.
Yes, sir. We have not included the architecture. So we have just mentioned about the what
No, you
we
have
can
to
do.
include in the paper, in
Yes, sir.
the review paper, the architecture of the all algorithms that you have found in the literature. I think around
Okay.
20 to 30 research paper you have covered.
Sir, 35.
35 is not a bad number.
Yes, sir.
And they are from which years?
Sir, post to 2020.
Post 2020. And they are all the research paper, not the review paper, right?
No, sir.
All the research papers, right?
Yes, sir. Yes, sir.
Okay, that's a good work. And come
Yes,
back to the comparative analysis slide.
yes, sir.
So you have used mobile net, right?
Okay. Computer analysis system. Yes, sir. We have used. Sir, no. We have mentioned about the mobile net because after going through some of the research papers, we have got one conclusion that because as mobile net is basically lightweight and it can be more sufficient for or more efficient for videography, so we have not concluded that we will use mobile net only, but one of the conclusion that we have got is that we can use a lightweight model along with CNN because only CNN I think it is more useful for static images, but as we know that our thought is about doing it in the website and also the videography part is there, so for that reason we have thought that CNN along with the
I
lightweight
got
model will
the
be.
reasoning, but you have included in the paper, right?
Yes, sir. So the basic reason for adding the mobile net is basically because in many of the papers we have got the mobile net along with CNN. So we have not mentioned that we will use mobile net only, but in many of the research papers we have got CNN and mobile net as one of the most prominent ones. So for that reason we have added a slide about that.
Okay, now come back to the comparative analysis.
Okay, sir. Sneha, are you there? You can share the comparative analysis.
Just 1 minute. How many techniques you have considered for the comparison?
So there are basically four techniques that we cover. Till now, we work on LSTM and
What are those four techniques?
so there's CNN, LSTM, reinforcement techniques, and one more is that I forgot the name. What is it?
Oh,
Sir, the yellow one.
YOLO. Yeah, it is.
Hold on. Yes, YOLO.
Okay. Now, where is the comparative table, comparative analysis table? Tell me the difference between CNN and LSTM.
Sir, basically CNN give the high accuracy for recognizing hand shape, but cannot capture movement between frames. But LSTM focus on movements and sequential informations, but they take more time and data to train. But LSTM takes short time. But CNN is useful for static recognition as well. But LSTM is good for video-wise recognition techniques, which we are mainly focused on.
So what component been included in the LSTM which makes it to enable this performance?
So we think to combine CNN and LSTM with YOLO V5.
No. I'm asking you that LSTM is capturing the motions, but इसमें ऐसा क्या इंक्लूड किया गया है, ठीक है, जो जिससे ये CNN से ज्यादा अच्छा परफॉर्मेंस दे रहा है?
सर सर बिकॉज ये मूवमेंट ट्रैक कर रहा है और CNN स्टैटिक इमेज को ही ट्रैक कर रहा है, वो मतलब
That's my
वीडियो वाइज
question.
ज्यादा
How it is tracking the movement?
by using sir unsupervised learning. It's take
I'm not getting it actually. Injaman and Sneha Sidur, you explain it properly. Have you included the architecture part here? LSTM is supervised or unsupervised?
so it is unsupervised.
Are you sure?
Sir, it is supervised, but sir,
How could I consider two?
unlike CNN, unlike CNN or traditional model, LSTM understand the time and the sequence. It's understand time and sequence, but CNN did not understand the time and sequence. It's only focuses on the current image.
But I can see some confusion here. You all the members tell me it is supervised or unsupervised. Injaman, Sneha, what are you doing there? Madhurjo,
Sir, am I audible?
you all are audible. Please speak.
Hello.
Sir, what was the question?
Question is that LSTM is supervised or unsupervised?
Sir, in case of LSTM, we can say that it is to an
Kind of
extent
neural.
supervised learning because it is used for long-term sequence prediction. But we cannot just give
For a
an
long-term sequence prediction, you can go for some another methods also. My question is not that. Straightforward question. If it is supervised or it is not supervised, unsupervised. Why you guys are confused on that?
So LSTM is supervised, but
So
LSTM can be in unsupervised or self-supervised setup also. It can be.
how could it
Sir,
be?
sir, in our basically LSTM is a kind of a neural network model, but in our project we are using it under a supervised learning because we are going to train it with a level gesture sequence.
तुम लोग जो बोल रहे हो ना उसका एप्लीकेशन बोल रहे हो, मेरा क्वेश्चन एप्लीकेशन पे है ही नहीं। मेरा क्वेश्चन सीधा साधा है कि ये क्या है एग्जैक्टली तुम लोग एक बार बोल रहे हो अनसुपरवाइज, एक बार एक मेथड को कैसे सुपरवाइज और अनसुपरवाइज for both you can use.
So it is exactly a supervised learning.
तो वही आंसर होना चाहिए। एक ही चीज दो कैसे हो सकता है? देखो, रिव्यू का मतलब ये है कि टेक रिव्यू में हम इतने सारे मेथड्स पढ़ा, उसके बाद कंपैरिजन में मैंने क्या बोला कि पिक 4 to 5 मेथड्स आउट ऑफ दैट एंड गो थ्रू इट properly, right? This is the last semester work I am discussing with you. Current semester work I have not yet discussed. Current semester means innovative methods. Out of this one, which one performing better, we are
Yes, sir.
going to modify or improvise the performance. That's this semester work, right?
Yes, sir.
मैं बाकी सबको भी
Yes,
बोल
sir.
रहा हूँ, अगर तुम्हें अभी भी लग रहा है तुम नहीं बता पाओगे तो यू कैन लीव राइट नाउ, प्रिपेयर एंड I will keep one day more. Tomorrow you can see for the presentation. But without preparation करके आओगे तो तुम लोग समझ सकते हो कि मैं क्या करूंगा, ठीक है?
Yes, sir.
तो इसमें से अगर तुम लोगों में से कोई एक भी हो जिसको जो कर रहा है पता नहीं है तो अभी के अभी लेफ्ट मार सकते हो, बट कल तक फिनिश होना चाहिए प्रेजेंटेशन। वन एंड एवरी पॉइंट वट एवर यू आर इंक्लूडिंग यू शुड नो। समझ में आ रहा है? हमें क्वालिटी में ज्यादा इंपॉर्टेंस देना है, क्वांटिटी में नहीं। तो क्वालिटी जो है, 4 मेथड्स रखो, इट इज ओके, यू आर नॉट टेकिंग 5 मेथड्स, 4 मेथड्स यू हैव टू नो फ्रॉम द स्क्रैच, ठीक है?
Yes, sir.
ओके, नाउ आ जाओ वापस। CNN कर लिया, LSTM कर लिया, और उसके बाद CNN LSTM, व्हाट इज दैट?
So that is a hybrid model.
Why you are making this combination?
Sir, because as I've already mentioned that CNN is basically used for static images. So one of the conclusion that we have got from the papers is that CNN along with a lightweight model can be more efficient in gaining the accuracy that we want. Because as we already know that our thought is to do the videography part. So if we do the videography part, I don't think that only CNN will be more efficient, because in some of the papers we have got that, for example, YOLO only, that we have got that CNN along with a lightweight model will be more efficient.
So here lightweight part is LSTM. Here lightweight part is LSTM.
Sir?
Where is the lightweight part?
So no, in this part it is not lightweight. We have not mentioned anything about the lightweight part, because we have kept some of the models, so we have not concluded that what will be the lightweight part.
What do you understand by the term lightweight?
Sir, we can just conclude it by saying that model will be more efficient in terms of videography.
देखो, इंजामान और सारे
And
मेंबर,
sir, for example, yeah.
हेलो, কোৱা, মই ক্লাছত আছো।
Hello.
যোৱা তোমালোক যোৱা, হা, মই ক্লাছত আছো এতিয়া।
Sir,
মই চাই লওঁ, মই চাওঁ তাৰপিছত কৈ আছো, তোমালোক যোৱা বাৰু, হা। See, Injaman, Sneha, Madhya, and Asidu. All the members, right? 4 members. Hello.
Yes, sir.
Yes, sir.
First,
Yes, sir.
what do you understand by light? अभी बता नहीं पा रहे हो, कोई दिक्कत नहीं, ठीक है? मुझे आल्टो फाल्टो आंसर
Yes,
चाहिए
sir.
भी नहीं है, मुझे करेक्ट आंसर चाहिए, हाँ। तो कल फिर से बताना कि लाइट वेट मतलब क्या होता है, ठीक है? एक लाइट वेट हम इसलिए यूज करते हैं मैक्सिमम केस में, जैसे योर सिस्टम, माय सिस्टम, that they are not workstations, they are not servers, right? We have to
Sir, the
work.
memory allocation comes there.
हाँ, तो मैं यहाँ पे ये बोल रहा हूँ, पूरा एक्यूरेटली देख लेना क्या किस लिए हम लाइट वेट बोलते हैं, समझ में आ रहा है?
Yes, sir.
ठीक है। और इसके बाद परफॉर्मेंस में क्या मिला आप लोगों को इन द कंपैरिजन पेपर? What you have got after the comparison? Tell me what you have got in the output, means after the comparison.
So after the comparison, we found that vision-based approaches domain modern SLR system due to scalability and easy deployment.
Now
Uh,
you tell me one method who is performing better in comparison to the others.
we use LSTM. It's work better than the other models, but we think for adding some extra stuffs into it, like Lightwell model for system completability.
That's not my answer. My question is very straightforward. After the comparison, what are the parameters you have taken for comparison? And with respect to the parameters, what you have got, which one is performing better? देखो मुझे लगता है तुम लोग प्रिपेयर नहीं हो. All of you are you hearing my voice? Say yes or no. I can see all of
Yes,
you.
sir.
Everybody speak up.
Yes, sir.
Yes, sir.
So I'm giving again 24 hours for this preparation. Tomorrow at the same time we will sit from the 2:30 onwards.
Okay, sir.
Here I am not going to consider any excuses. पूरे रात पढ़ो या जो भी है अच्छे से पढ़ लेना अभी जो किए हो, ठीक है, एक रिव्यू पेपर का और एक कॉम्पैरेटिव एनालिसिस का, और इसको एक एक चीज कल जो भी क्वेश्चन पूछूंगा सब आना चाहिए, सब पढ़ना चाहिए, और जो भी स्लाइड्स होगा इसमें आप लोग एक्सपेरिमेंटल रिजल्ट्स का कुछ आउटपुट पुट करोगे. जैसे अगर इमेज की बात हो रही है तो इमेज डाटा सेट के ऊपर और उसका रिजल्ट्स के ऊपर ये सब पुट करोगे, और दोनों पेपर पूरा रेडी होना चाहिए कल तक, क्योंकि लास्ट आई एम नॉट गोइंग टू मेंशन द नेम्स, आई कैन सी द एआई इनपुट देयर. That should be properly written by you. Remember, that should not be copy and pasted. I'm not going to accept any similarity index higher than 10%.
Yes, sir.
ठीक है, सबको बोल रहा हूं सुधर जाओ. जो भी अगर कुछ दिए हो वो चेंज करके कल तक मुझे फिर से देना. हर एक ग्रुप को बोल रहा हूं, बिकॉज आई एम गोइंग टू सेंड यू फॉर सम गुड इंटरनेशनल कॉन्फ्रेंस और जॉर्ड एल्स for the presentation. If you walk in this way, if you take this so casually, that is not going to be accepted. ठीक है? 2:30,
sir.
mark the time. Tomorrow again we'll sit.
Sure, sir.
Thank you.
Okay, sir.